Hello and welcome to our video lecture on operations on functions. In our last video, we learned about relations and functions as well as their domains and ranges. In this video, we want to concentrate on the four basic operations that can be performed on functions. All right, so we have previously studied the four basic operations of addition, subtraction, multiplication, and division on mathematical expressions. As it turns out, a function is also a special kind of mathematical expression once defined, and we can perform the same operations on functions as well. So the definitions are quite straightforward and simple, and here's the visualization. Like here we have a function f and a function g, and when we add them we get this other new function which we call the sum function. So that itself is also a function. As far as the domain of the sum function or any of these other functions is concerned, we basically need to just take the intersection of the two domains. So basically the output of f added to the output of g at any given point will give you the output of f plus g at that point. And you can see that here visually. When it comes to addition and subtraction, you can kind of visualize it pretty easily. Like here you have a function f and a function g. When you subtract it, you get this lower function f minus g. Once we get to multiplication and division, the relationships become quite complex, not easy to guess or visualize. So here we have the sum function, the difference function, the product function, and the quotient function. Remember we discussed about the fact that the domain of each of them is the intersection. The only exception is f over g, where we need one extra requirement, and that is of course the fact that g of x should not be 0, because otherwise the quotient here becomes undefined. So that's the extra requirement for only the quotient function. So basically f plus g of x, the value or the definition of f plus g of x is just going to be whatever f gives us at that point. Let's say x is here, plus whatever g gives us at that point. So the output of f plus the output of g. For f minus g of x, it's going to be the output of f of x, minus the output of g at x. For the product function, same way, and also for the quotient function. So here we have a couple of functions defined for us. F of x equals x squared plus 1 and g of x equals 5x minus 3. We have a quadratic function here and a linear function here. We want to perform these basic operations on those two functions. So basically we know from the definition that f plus g of x is just going to be f of x plus g of x. So we know what f of x is. It's x squared plus 1. And we know g of x is 5x minus 3. And because we're adding, we don't really require parentheses around the 5x minus 3. If we were doing any other operation, we would put it, as you'll see in a minute. So now it's just a matter of, simplifying this expression. And we know that the only like terms are the 1 and negative 3. So we end up with x squared plus 5x minus 2. And this is basically what is meant by f plus g of x. Now for f minus g of x, it's going to be very similar. So we're going to get f of x minus g of x So f of x is x squared plus 1 minus, this time we do need parentheses because g of x has more than one term and this negative needs to be distributed by them. So we write minus quantity 5x minus 3. Now we're going to just distribute and simplify. So x squared plus 1 minus 5x plus 3. So we end up with x squared minus 5x plus 4. And that is what f minus g of x is going to be. So we can just say f minus g of x equals x squared minus 5x plus 4. Now for f times g of x, by definition we know that f times g of x is going to be f of x times g of x. Now we know that f of x is x squared plus 1 and g of x is 5x minus 3. So we parenthesize both of those and now we just go ahead and multiply them in the same way that we learned when we covered polynomials. So we'll go ahead and distribute the x squared into this group, and when we're finished we'll go ahead and distribute the 1, then we'll combine any like terms. So we get 5x cubed minus 3x squared. Now we're going to distribute the 1, so plus 5x, and then positive 1 times negative 3 gives us minus 3. So now we see if we have any like terms, and we notice that we do not. So we're basically finished. So as far as what f times g of x is concerned, we just have 5x cubed minus 3x squared plus 5x minus 3. For f over g of x, we also apply the definition. When we want f over g of x, we need to calculate basically the output of f and divide it by the output of g at that input x. So we know that f of x is x squared plus 1 and g of x is 5x minus 3. So that is basically f over g of x. Now with this one in particular, we do want to make sure that we avoid 5x minus 3 being 0, which means x equals 3/5. So when we want to write the domain for each of these, notice that these are two polynomials, and we know they're very well behaved functions with domains being all real numbers. So when you take the intersection of all real numbers with itself, that's just going to be all real numbers. For basically all three of the first ones, the domain is just going to be negative infinity to infinity. The only exception being the last one, we need to make sure that we exclude 3/5 from the domain of f over g. So basically the way we handle that is we'll say negative infinity all the way to 3/5. We're going to exclude that, so we'll use parentheses. Union, we can have everything after 3/5 as well. So 3/5 comma infinity. So that's how we compute the domain for those. Now when it comes to f plus g of 2, for instance, here we're evaluating these specific outputs like f plus g of 2, and we notice that we could do it two ways. Since we've already calculated f plus g of x, we could go ahead and just use that and plug in the 2 into this expression to give us f plus g of 2. So that would give us f plus g of 2 equals 2 squared plus 5 times 2 minus 2. So that's going to give us 4 plus 10 minus 2, and we know that that's 12. And that is f plus g of 2. Now, just so that you get more depth into this situation, notice that we could have also done it without using this. In other words, let's suppose there was a problem that didn't need you to find f plus g of x, and they only asked you for f plus g of 2. If that were the case, you wouldn't have to go sit there and calculate f plus g of x so that you can then plug in 2. You could have just done it directly. By definition, notice that f plus g of 2 is going to be f of 2 plus g of 2. So we know that f of 2, remember, that means wherever you see x in the definition of f, substitute 2. So that would be 2 squared plus 1. And g of 2, wherever we see x in the definition of g, we're going to substitute 2. So we get plus 5 times 2 minus 3. So we end up with 4 plus 1 plus 10 minus 3. So that's 5, 15, 12. Not surprisingly, we get the same result. So just remember, two different ways of handling the same evaluation. Like that. So again, you could use the result you obtained for f plus g of x here. Let's make it look better.
I'm not sure.
Or we could do it directly. All right. So now we're going to handle f minus g of 2. Again, we have already calculated f minus g of x. So we could go ahead and use this fact to calculate f minus g of 2 for the specific input 2. So we would get f minus g of 2 equals, wherever we see x in this expression, we're going to substitute 2. So we get 2 squared minus 5 times 2 plus 4, which gives us 4 minus 10 plus 4. So that's basically 8 minus 10, which is negative 2. And that is f minus g of 2. Notice that we could have also done it directly again by just computing, by realizing that f minus g of 2 by definition is f of 2 minus g of 2. We could have bypassed having to use this altogether, and then we could have just gone directly to the definitions of f and g. So f of 2, that means 2 squared plus 1, minus, let's not forget the parentheses, g of 2, which is going to be 5 times 2 minus 3. So we end up with 4 plus 1 minus, that's 10 minus 3, which is 7. So that's 5 minus 7, which is, again, not surprisingly, negative 2. So we end up with, once again, f minus g of 2 equals negative 2. In agreement with our indirect approach by first computing f minus g of x and then evaluating for the specific input 2. And of course, this goes on with f times g as well. So we know that we can use this result, which we've already obtained, for f times g of x. So we can say f times g of 2 equals, wherever we see x in this expression, we're going to substitute 2. So we get 5 times 2 cubed minus 3 times 2 squared plus 5 times 2 minus 3. So we're going to get 5 times 8, which is 40, minus 3 times 4, which is 12, plus 5 times 2, which is 10, minus 3, and that gives us negative 12 plus 10 is negative 2, minus 3 is negative 5, so 40 minus 5 is 35. So that's f times g evaluated at the input. I mean f times g evaluated at input 2. And let's do it directly now. So to do it directly, we don't use the result we obtained here. We don't rely on it. We just go directly to f of 2 times g of 2. And notice f of 2, we've calculated a few times already. That's 2 squared plus 1 times g of 2, which is going to be 5 times 2 minus 3. So that's 5, and that's 10 minus 3, 7. So we get 5 times 7, which is, of course, 35. So whether we calculate it directly by going just straight to f and g definitions, or indirectly by first computing the product function for a general input x and then just substituting the specific input 2, we get the same result. The last one is f over g of 2, and of course 2 is not a problematic number. It is in the domain of f over g because it's not 3/5, so we can go ahead and compute it safely. So f over g of 2. Now notice that in this case, whether you do it using this or go directly, it's going to be pretty much the same thing. So here we're only going to calculate this once, and we're going to get 2 squared plus 1 over 5 times 2 minus 3. So we get 5 over 7, and that is f over g of 2. And that brings our video lecture on operations on functions to a close. So please make sure you understand these simple but fundamental concepts that you will be seeing for the rest of your endeavors in mathematics. And stay safe until our next video.